Hello again, Algebra 1 students. We are in Unit 3, Week 2, Family Function Syllabus. We are in Tier 3, Lesson 2, check off your booklet. Lesson 2, Continuous Absolute Value Function Characteristics. All absolute value functions have only two options for end behaviors. So knowing if there is a vertical flip is present determines the end behavior. So where do we get the vertical flip again? Well, right here in front of the absolute value expression, if there's a negative present, then that means we have a vertical flip which turns the absolute value upside down. So knowing that that vertical flip is there, we would know whether or not we have a V that is shaped upside down when there is a vertical flip like this, or a V that is upside right when there is no vertical flip like in the parent function. So let's go exploring. So right here, we can already see that there is a vertical flip. So we know that it is going to have an end behavior like this over here. So as x approaches infinity, y will approach negative infinity, and as x approaches negative infinity, y is going to be approaching negative infinity. And we can see that if we sketch it, because the x going this way is toward infinity, and the x going this way is towards negative infinity, right? It doesn't matter which way it goes. Both times the y's are approaching negative infinity when there's a vertical flip. Now, over here, we can see that there's not anything in front of the absolute value expression. So that means it's going to be a v that looks like this one over here. So as x approaches infinity, y will approach infinity. And as x approaches negative infinity, y is again going to approach infinity. And if we sketch it, it makes sense because as x is going this way, going toward infinity, the graph's going up toward y's positive infinity. And as x is going this way toward x's negative infinity, the graph again is going up toward y's positive infinity. So let's take a look at a couple examples. So right here we see negative absolute value of x plus 2. So we know straight away that the shape of our graph is going to look like that. We don't even have to think any further than that because we know there's a flip involved. Okay? If you want to draw a table in this open space, go ahead. I don't need to because I understand where my parent function is. And it's just going to be flipped and then up 2. So the graph will look like this. My domain, well, this goes on forever this way, it goes on forever this way. So my domain is definitely going to be negative infinity to positive infinity. My range is up and down. So I'm definitely going to hit negative infinity with my range, but I'm going to stop, and it's going to stop right here at the 2 value of y. So I'm not going to go any higher. 2 is the highest I can get. My vertex on this graph is at this point with the 2. So my vertex is 0, 2. My maximum, the highest point I get to, is my vertex again, 0, 2. Remember when I said minimums, you could say either none or whatever the smallest number or largest number is. Well, the smallest number, so that would be either none or negative infinity. Now let's look at something a little different. Our increasing and decreasing interval. Well, this graph is increasing. Remember, dealing with intervals, we only look at the x values. So only these values right here by x. So it starts increasing all the way out here at negative infinity. And then it stops increasing at the vertex. Well, the x value at the vertex is 0. But that's also where it starts decreasing or going down this way. So it starts decreasing at 0 and it decreases all the way out here to the positive infinity. So our increasing interval is negative infinity to 0. And our decreasing interval is 0 to positive infinity. So now let's talk about the end behavior of this graph. Well, as x approaches infinity, the graph is going down. So y is approaching negative infinity. And as x approaches negative infinity, y is still going down. So y is still approaching negative infinity. Let's do one more example so that you guys can have a little bit more understanding in depth. Ooh, check this out. I see a vertical reflection. So I know for sure that my graph is going to look like that. You can make a table if you want. I'm not going to make a table. I'm just going to use my knowledge of the parent function to know that it's been flipped upside down with that reflection, and that I'm going to go down 5. So it's going to start right here at a negative 5, and it's going to be upside down. So that right there, that point, that's going to be my vertex. So my vertex is going to be 0, negative 5. So I can come down in and fill that characteristic out. I usually always like to try to find the vertex first, just so you guys know, because it makes everything else just flow a little nicer and a little easier. Well, now let's do my domain. Well, my domain is all x values. Well, even though this graph's down here, it's still going to hit every single x value. So my domain's going to still be negative infinity to positive infinity. Now my range is going to start at the bottom and work up. Well, I'm still cool on my range, right? Because I'm going to start at negative infinity. But when I get up here to negative 5, there's no y values above it. So negative 5 is the last possible y value. So therefore my range is negative infinity to 5. The maximum is just my vertex, 0, negative 5. And remember, the minimum, you could either say negative infinity or none. So let's look at our increasing and decreasing intervals. So remember, intervals, we only deal with the x values, and it starts decreasing all the way out here first at negative infinity of x, and then it stops increasing at the x value of the vertex, which is 0. So that's our increasing. And then our decreasing starts at the vertex and goes all the way out to the positive infinity of x. So it starts at 0 of the vertex and goes all the way out to positive infinity. So those are our increasing and decreasing intervals. And then when we're dealing with in behavior, as x is approaching infinity, which is this way, the graph is going down. So y is going to approach negative infinity. And as x approaches negative infinity, which is this way on the Cartesian plane, it is still going down. So y is going to still approach negative infinity. Congratulations on completing the booklet. Good luck on your practice sets.